couple of different pieces of information that I need to give to you. Number one is the following. Scientists don't always have tools at their disposal in order to manipulate things in the way that they had hoped or that they desired. It's important to recognize that for a long period of time, we had no idea that microscopic organisms existed because of the fact that we didn't have a tool to see microscopic organisms. The same thing goes for scientists today. We have a lot of tools at our disposal. We have a lot of things that allow us to do certain manipulatives with electricity or viewing things in that are really small that we can't see with the unaided eye, or large-scale modeling. Those things didn't always exist. They exist today. But we still have limits on things. We don't have an electron microscope in this classroom. That would be great for us to see certain things and make certain discoveries, but we just don't have the access to it, though other scientists do. What happens when a scientist makes a discovery, or they publish an article, or they publish a paper? What is the next step for that scientist after they have done that publishing? What's that?
Prove it.
No, they've probably already attempted to prove it. So peer editing has probably happened, and other scientists have probably argued and said, prove it. They've probably said that at this point. What might a scientist do after the proof has occurred? Yes?
Try to learn more about it.
Try to learn more about it. Find the other subparts of that maybe I don't have discoveries of, and so therefore I want to try to understand those little pieces that I don't understand. That is definitely a possibility. What else might they do? Okay, maybe I need to ask in a different way. If you're a scientist and you make a discovery, you publish your discoveries, what do you then want to do with that information? Share it. Share it. I might want to publish it in a peer-reviewed journal so that other scientists can read it. I might want to, at some large conference, share the information that I have gained with other scientists. Why is this valuable? So other people know about it. Because why? I mean, why does that matter that other people know about it? Yes, sir, Mr. Cottrell?
So they can also research it more?
So they can also research it. And that might get into this idea of proof. Like, okay, well, you did all these experiments, and I wonder if I do the same experiments, do I end up with the same outcomes? Or is there specific variables that change given location or other things, right? What should cause a scientist to say this is the conclusion that I have drawn?
After they know every outcome.
After they know every outcome, I agree. And so what is dictating that outcome? Or what is dictating them saying to themselves or other scientists, this is the case?
They proved it all.
How so? What did they look like to prove, or look at to prove it?
The product itself.
Maybe. What happened before the product? What? The recorded data. The data should tell the story, right? Do scientists and people in general, do they come to data with preconceived notions and this idea of bias, where they have a belief system that they've already set up in their head, and that belief system, they look for data to support the belief system? Oh yeah, happens all the time, doesn't it? I mean, open up social media right now and I guarantee you can spend less than a minute scrolling and you will find it, right? Individuals with belief systems that say, okay, I gotta find some evidence to support my belief system. As scientists, we should be mindful of that. And we should be mindful of the fact that we have our own biases in our own brains. There are things that we believe about the world and the things around us that cause us to come to data and say, based on these things that I understand and I believe, I want the data to say X, Y, or Z. And it's important as a scientist to eliminate that, to step away from that, to say, I understand I have biases, but I'm going to do the very best that I can to minimize those biases. Okay? Oftentimes, people in the general public, they will have something like this up here, where a whole bunch of data has been collected. And we got just a simplistic graph, right? X and Y axis, data point, data point, data point, data point, data point, data point, collected from an experiment. And a line of best fit that fits to that data point, to those data points. And in this case, we've got these data points up here on the board that are showing that there's an increase from left to right. We seem to have data that's all trending in the same general area. But then we end up with this up here. Right? What do we call these things up here? Outliers. Okay, outliers. A lot of times the general public, they will look at an outlier and they say, ah, that proves you wrong. Your ideas are incorrect. And the scientist is like, no, I'm not incorrect. Look at the data. And the general public's like, no, look at that outlier. That outlier fits my narrative. And scientists is like, but all this other data says this. A scientist does have to eliminate outliers and maybe justify outliers as to why they ended up happening. Maybe there was a variable that happened during the experimentation that they need to point out and say, well, this changed when I experimented at one point. Maybe I was running my experiment and, I don't know, a big wasp grew through the experiment and caused the data to change. There's lots of things that could cause that data to have an outlier. The general trend is, though, that. So I think it's important to recognize that early on in this class. We are looking for the general trend in data. We are looking for the general trend in order to do what? What is the ultimate goal in looking for trends in data? What? Could be a proof of point, maybe, maybe not. Maybe it's just knowledge for knowledge's sake. What is the general thing that we want to do when we have a trend in this data? All right, maybe it helps to ask this way. We've graphed up to this point, right? Is there more information up here?
Yes.
Oh. Did we experiment up to that point? No, we didn't experiment up to that point. The data seems to stop up to the top data point, right? What does this data help us do then? What do these points on this graph help us do? Predict where. Make a prediction. The goal of science is to make predictions. Accurate predictions. Okay? We want to make predictions, and that's what today's activity is about. You will be scientists today. You will be scientists in this class every day. Scientists are not individuals who throw a lab coat on and sit inside of a lab and just stare at a computer screen or stare at an experiment every day. Scientists are people just like you. They look like you, and 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 they look like you. You are a scientist, okay? They look exactly like y'all. Sometimes in their job, they are allowed to put on jeans and a sweatshirt and go outside with mud boots and get muddy. In their possibility or in their job of trying to predict outcomes to specific experiments. Okay? We will be scientists every day in this class. It will be expected that you are a scientist. That means scientists come with minimizing their preconceived notions and saying the data is supporting the idea of. Okay? We need to be okay with stepping back and saying, I relinquish control over my prior knowledge, and I'm not going to fight with you over something that I may or may not know. Or maybe the data was given to me in the wrong way. Maybe somebody gave me an outlier and said, that is wrong because of this outlier. And you're looking at a general trend of data going, I got to reconsider my thinking. Okay? Today's activity, there are rules. The number one rule is you cannot move from your spot. You do not have horizontal, lateral, forward, backward, up, down movement. You have to stay in your general area. Okay? You will all have different perceptions. You need to use your different perceptions to develop a model. You do not have tools that you can throw at the object that you are going to be developing a model of. Though sometimes in some experiments, we do have tools that allow for things like that to happen. We can manipulate systems at time. Okay? In this case, you do not have that ability. The goal of this class as a whole is for you to develop a model that accounts for all of the parts of the structure that you are going to be looking at. Okay? What questions do you have so far? Number one question is, what in the world are you even talking about? What is the object? Well, here's our object. Individuals that are closer to it might have more perception than other individuals that are farther away. Sometimes we cause people to get lost in the noise. I'm going to give you about a minute to kind of start wrestling with what you see and what you have going on inside of your brain. But ultimately understanding that we need to develop a what? Model. And we said a model is any conceptual representation, 3D, pictorial, computational, etc., that explains a phenomena or a concept in a physical system or process. Let's simplify that in that we need to develop a representation of the cube as it exists without the ability to move around. We must account for all sides of this object. Okay? Is that clear? All right. Here's your object. I'm sure it's not going to fall. There we go. It's funny how every group is slightly different. Slightly different dynamics. The first group just started screaming.
I'm not the best.
I see 3 and 3 and 2.
I'm not the best person. Can't see the top or below the other.
Not model 1, mystery cube page. Mystery cube page is where we are creating our model. See, page number 21 is your mystery cube page. Model 1 will be what we come back to when we get to the end of Unit 1. So page 21 is where this model will go. I don't think this group has to worry about getting lost in the noise. Ooh, something's starting to emerge. What is starting to emerge?
talking to each other.
On the side that we can't see.
Oh, there's some communication that's happening. Do scientists communicate? Oh. Is there an organization to how scientists communicate? Oh, how could we use organization in the classroom to communicate effectively?
You can all say the corner of the side or the side.
Could.
What's the blue?
There has been a proposal, Mr. Wittenbach. I'm noticing a few leaders are emerging, and there has been a proposal. Mr. Cottrell, could you state your proposal?
Yeah, we can all say, we all should tell each other what sides say, what's different about the side.
I'll show you. So it says Elma right here, with a 4 on the top corner, and then the bottom corner is a 2.
The white
What top corner?
My top right. It would be left for you.
Andrew.
the white one.
Andrew, what's that over here?
My right, my top right, it's a 4. Bottom left is a 2.
Did y'all get that?
Or on this side right here.
Elma, A-L-M-A.
Is there anything else about that box that would be useful to share with the people that cannot see it?
What color is it?
There is a question being asked.
What color is it, Andrew?
It's white.
Interesting.
Alright, Andrew, this side we got the other one
The
over there.
one, Allie or Warren?
Or outside we do. That one's blue. It says Rob. And in the top right corner it says it has a 3. And then in the bottom left corner it has
It's blue, a 3 closest to.
the one closest to Allie is blue. The one closest to Warren is white.
What's the number on that?
I don't know if everyone got that. You're probably moving too fast, Mr. Williams.
Can you restart?
Slow down. Not everyone writes at the same
The
speed.
side that's closest to Allie is blue.
Mr. Williams, you're not slowing down. You're continuing to talk and people are waiting.
Allie's closer.
Hold on a second. Mr. Williams, you're doing a great job of taking a leadership role. I appreciate your leadership role. Big thing about leadership is that you have to have followers. You gotta have followers if you're a leader. If you're leading without followers, then you are just running away from them. Which may or may not be the case depending upon what you're doing.
This side closest to Allie, that top left is a 4. And that bottom one is a 2. And it's
Alright, Mr. Williams, let's go back to you. The blue side next to Allie, I think is where you were at. Continue.
It says Rob for the name.
With 2 B's, right?
No, one.
Oh, with 1. Oh, you need to make sure that you are extra specific.
ROB. Top right corner has a 3. Bottom left corner has another 3.
Is there any other piece of information regarding that section of the box that you would like to share with us, Mr. Williams?
It's blue.
It is blue, he said. Any other information on that side of that box that you find valuable to share with us?
Not that I can see.
Not that he can see. Maybe Allie is closer and she has information she would like to share.
On this side?
Yes, I think that's the... Is there anything on there that we need to share besides what has already been shared?
Did you already say blue?
He said blue. Yep.
Then no.
Yeah.
Well, there's like a plastic wrap around it.
Ooh, interesting. You know, you're the very first person all day long that brought that out. Nobody ever said anything about it.
What?
There's a plastic wrapper around it. Interesting. You are the absolute very first person that has said, here is what I see, and there's a plastic wrapper around the whole thing. Interesting.
What's your side?
Okay, who are we going to? Cottrell? Is that what you said?
I said Warren.
Warren. Okay, Cottrell's got his hand up though, so I think he's ready to share.
Okay.
Warren's still writing.
Is everyone done writing? No, that's fine. Okay. So, our side is white. And the name in the middle is Alfred. It's A-L, and then Fred with all, like how you normally spell Fred, F-R-E-D. Okay. The top right-hand corner is number 6. And the bottom left corner is number 2. That's what it says.
Mr. Warren, they called on you just a little bit ago. Mr. Warren, do you see anything that you need to point out that is different from what Mr. Cottrell has pointed out? Or something that maybe he just skipped over that you need to make extra special attention toward?
There's also plastic wrap.
Also plastic wrap, okay? Anything else? Okay.
So I noticed the colors. My side and Allie's side are both blue. Warren and Andrew's side are both white. So I'm assuming the top and bottom are both red.
Interesting observation.
Angelina, what does your side say?
Mine says Roberta. It's just Rob, one B, and then ERTA. And then in the top right, it's 7, and the bottom left, it's 3. And
You said it was blue?
Miss Lily, I believe you had something you'd like to say.
Actually, I want to ask something. Someone over here, what does the name say over there?
It's Alma. A-L. What's the name on the side?
Which side?
The blue side.
I'm noticing something as well. Each of the opposite sides have a name that have to start with the same thing. So Alfred and Alma both start with A-L. Then Roberta and Rob both start with Rob, of course.
It's
So I'm
red on the pie.
Continue, Miss Lily.
Sorry. So I'm assuming the red side that's on the bottom is going to start with FR or something along the line of Frank. I don't know what yet.
Go ahead.
Andrew, I didn't catch this side.
yeah, what's the top side?
What's the top side? We need somebody to assist with the top side. Maybe we only have 1 or 2 people that can see it well. Allie, I think you're up.
Top side is red. The name is Frank, F-R-A-N-K. And the number on the top right is a 5. And the number on the bottom left is 4.
Wait, Andrew, what was your side?
What about it?
Like the entire thing, I didn't get it.
White. The name is Alma. A-L-M-A. Top right is a 4. Bottom left is a 2.
Thank you.
Excuse me.
I've also noticed that on the opposite sides, the bottom numbers are always the same.
Oh, Mr. Hunter, you are moving way too much. One of the rules was not to move. Restate that again. I apologize. I got sidetracked.
So on like opposite sides, so like on both of the blue sides, the bottom number is 3 for both of them. Like the bottom left.
The top side of nothing. On opposite sides.
Hold on 1 second. I think we need to go back to the statement that was made right there before we go to them adding up to 10. Go back. Because I was not understanding completely what you were saying.
That the number in the bottom left-hand corner on opposite sides is the same.
The bottom number on opposite sides, the bottom left number on opposite sides is always the same number amongst opposite sides. Is that true always? And is it supported in each one of them?
We don't know.
Why don't you know?
Because we don't know what the bottom is.
You don't know what the bottom is, but you have another 4 sides that you can do a comparison. Does it hold true in the other 2 sides that are the same color?
Yeah.
Okay, so far that holds true. Alright, so we can, thus far, we can make the statement that the bottom left number is the same on opposite sides. Is that all we know?
Yeah.
Okay.
What's the numbers on those? No, I just spelled it.
Okay, so it's 3 on the bottom left and 7 on the top right. And the name is Roberta, so R-O-B-E-R-E-R-T-A.
Miss Lily, you have had your hand up for a little while, and Miss Allison, you have as well. Miss Lily, go first, then Allison.
Okay, so back to what I said about the names on each side starting, or the names on the opposite side starting with the same thing. I think I also noticed that one is more of a feminine name, one is more of a masculine name. So I'm assuming that the bottom from across from Frank, is going to be more of a feminine name, and I've come up with one so far, and I came up with Francesca. But that's not a definite answer.
Okay. So the statement that Lily made was related to the fact that each opposite side seems to have what would be considered a masculine name, and the other side has what would be considered a feminine name. What caused you to say that that bottom name might have the first letters that it has? Or what caused you to start with a specific name? I'm trying to say this in a way that doesn't give away... I'm looking for evidence as to why you chose that name on the bottom.
Oh, I thought I explained it earlier. Each side, so let's say both white sides. This side starts with Alfred, and the other is Alma, and they both start with A-L. And the other side, the blue side, one starts with Rob, and the other one is Roberta, so they share Rob in general. And so, Colin, excuse me. So I can assume that Frank and the one below it will somehow relate to each other with the first few letters of the name.
Okay, gotcha. I understand. Mr. Williams, you got the floor, and then Brianna, we're going to you. Ooh, wait a minute, we skipped over Allie. Allie, you are first. Then Mr. Williams, then Brianna.
I was gonna say the same thing Willie said, but now I'm realizing that it's more like Rob and Roberta. They both share the first three letters. Frank, or no, never mind. Alma and Alfred share the first two letters. What if the bottom one just shares the first letter? That's 1, 2, 3.
Good. Do we have any way in which we could state the number of letters that it might share? So Mr. Williams, apparently, we were coming to him next, then we were going to Brianna, so maybe he's got something to say about that. Go ahead, Mr. Williams.
Two things. Like you said, the bottom left corner for AL, for Alfred. On the white side, it's Alfred, which is AL. And then on both sides, the bottom left corner is number 2. And then on the blue sides, ROB has the 3. But I've also noticed that in the top right corner, the number of letters in the name is the number that's in the top right corner. And the numbers that they share on other sides in the bottom left corner.
I see a few people shaking their head in support. Brianna, we're over to you. So the upper right-hand corner for the Frank side is a 5. And the bottom left corner for the Frank side is a what? And we have said the bottom left-hand corner represents what?
The
amount of matching letters in the opposite side. Okay? Mr. Hunter?
So I noticed that, like, with the white side, just the first 2 letters. If you look at the bottom left, it's a 2. And then the bottom red side, the bottom left is a 3, and then it's the first 3 letters that match. And then the bottom left on the top, there's a 4.
Okay. Does what Mr. Hunter say also support what has been said prior? Okay. Yes, ma'am?
I think that the name is Fran, the first 4 letters the same.
Frankie.
Okay. So we are now adding a prediction to what Mr. Williams said. The prediction is this is the term that would match best based on what Mr. Williams had said, in that the upper right-hand corner seems to be the number of letters. The bottom left-hand corner seems to be the number of similar letters. The bottom left-hand corner for Frank was 4, so we're making an assumption that the bottom one is going to have 4 letters that are the same. What about the bottom right-hand number on the, or the upper right-hand number on the bottom of the box? Allison. Allie, sorry.
So, this ties into that question. See, like how Rob has 3 in the top right, Roberta has 7 in the top right, and how it matches the letters of the name. I don't think we can find that number until we know what the name is.
Okay. So you are going to make a prediction, and then you're going to go to the data and see if the data supports the prediction? Is that how science works? She says yes. She's like, I don't know what you're asking, and I feel like it's a trap, but I'm going to say yes. Mr. Lauer.
Going back to what Warren said and how top right hand on the opposite side has a 10. I think the bottom top right hand will be 5 as well, because the top right is 5.
Okay. Yes, sir.
Well, kind of what Eli said, but wouldn't it be the 4? So, wouldn't it be a 6? Right?
You're asking for my answer. I'm looking for you to be scientists.
Well, I think it would be 6, right? Because 5 is the. Think about this. 1, 2, 3. Yeah. It's 5.
Okay. And what is your justification for it being a 5?
Well, because Rob and Roberta is 7, and Rob is 3, and that's 10. Then Elma and Alfred is, or Alfred is 6 and 4, that's also 10. And then Frank is a 5, so then the bottom one will also have to be a 5.
Okay. So assuming that the upper right-hand numbers all add up to be 10, then on the bottom of the box, the upper right-hand corner is a 5 for, on the top, the upper right-hand corner is a 5 for Frank. So if it's going to add to 10, the bottom would have to be 5 as well.
But it can't be, because then it's the same thing, right?
Could be
Brandy with a Y.
Please pardon the interruption, and just a reminder, one last time, girls, if you're going to play powder puff football, so 9th through 12th grade girls interested in powder puff football, make sure that you get on the Market website and order your shirt. If you need to stop by the office and pick up a sheet with the link to the website, you can do so. Also, you should have an email from me from about a week ago that explains exactly how to do that. If you do not order your shirt, you don't play, and make sure you choose the right grade. Could Eric Lake stop by the office, please? Eric Lake, stop by the office, please. Thank you.
All right. I had a number of people that
Ariana
said, so what's the
Lopez
answer?
also stopped by the office. Ariana Lopez, thank you.
Do we have evidence to support the answer that we've given?
Yeah.
Right now, the evidence is pointing towards the bottom of the box being what name? Franny. Bottom left-hand corner being what number? 4. Upper right-hand number being what? Color of the box? Red. And I think that accounts for everything. Is there going to be plastic wrap on the bottom as well? Okay. I think that accounts for most of it. A couple of things that we didn't talk about. Color of the letters. We did not talk about, what was the other thing? Oh, letter, first letter versus the rest of the letters, uppercase, lowercase. We didn't talk about that. I think it is important for us to recognize this. 1, we just developed a model. We just created our very first model in class. Well done, you did a great job. You have evidence to support the outcome that we have. You have evidence to say this is what we predict it to be based on the evidence that we have in front of us. That's how scientists work. Scientists work by saying, I'm making a prediction in relationship to the evidence that I have in front of you, or in front of me. If I was to change some of that evidence, would you be open to changing the name to a different name?
Yeah.
Okay. Would you be open to changing the number or the color? Okay. That's how science works. That's how scientists work. That's what's most valuable here. It is about the process and not so much about the outcome. And I'm always going to have somebody that's going to walk out the door and be like, Mr. Winter, what's the answer? And say, what is the answer? You have it. What's the answer? You have Franny, you have your numbers on each side, you have the color, you have a working hypothesis as to what it is right now.
Okay, so we have evidence to point out what it could be, but we don't know for sure what it is.
That is true. Do you suppose that happens in science?
Yeah.
Yeah, you bet. Do you guys think the things that I learned in class when I was in middle school and high school are the same things you learn in class today in science? No, they aren't. Things have changed. There is new evidence that is presented all the time with new technologies and new developments. And therefore, our models and our understanding should change along with them. We saw that happen over the last 2 years. We saw schools shut down. We saw businesses shut down with the advent of a pandemic. We saw changes that happened not only in the population of humans, but the population of the virus and how it was spread, and people that were susceptible to it versus people that weren't susceptible to it, and the way that we treated things. That's how science should work. We saw science in real time over the last couple of years. We should always be open to changing our interpretation and changing our mind based on how evidence, or what evidence, comes to us. Okay? Well done today. I will take a grade on this model, so we'll have to finalize this on Tuesday and make sure everything's in there. It will be your very first model that's in the grade book. We'll continue having a conversation, and we'll take a little bit of time to wrap that up on Tuesday when we come back. Yes? You will not be here, so you will need to do that, so then, and then get it turned into me. That might require you to have a little bit of conversation with a peer outside of class after we've had that conversation, so that you know that your model is finalized based on what the consensus has been amongst the your classmates, amongst the scientists in this room. Okay? All right. That's all I got for today. I hope you guys have a great weekend. It's a long weekend. And then we come back and we are rolling into the rest of September. It's my favorite month. September's awesome. I like October too. I do like November, but September and October are my favorites. I love the fall.
Now it's open day.
Thank you for putting the chairs up. Greatly appreciated.
That was a lot easier.